Okay, 5.3 day 2, we're remembering these properties right here. So 1, 2, 3, 4, 5, and 6. Okay, those properties we're using, refer back to your notes for those properties here. Okay, so the first one here, number 32, we're using this property here. You can kind of think this to the outside equals inside here, right? So those would equal. So if you're looking at this stuff here, if it have this and this is the same, they kind of cancel out and you get, yeah, you have your answer there. Okay, so if you're looking at this, if these two are the same, I know that this is equal to 19. Okay, using that answer there. Okay, if those are the same, we know it's 17 and 1/3. Okay, and this would be the same as log base a of a to the 1/2, right? 1/2 is the square root, so you get 1/2 as your answer. 34 asks us to explain in your own words what log base a of x means. Okay, so yeah, you can think about it's a must be raised to some power to give you x, and that's what we do to find what the log is. Okay, with these we're really using the same property as we did up here. So if you're looking at properties, property number 2 again. So log, if there's nothing written here, it's implied that it's a base 10. So remember, when those are the same, we know our answer is just 4.3. Okay, so square root of 3. Okay, natural log is the same as log base e. Okay, so that log base e is our natural log. So of e to the pi, so those e's will cancel, so you just have pi. Same thing here, log is, it's log base e, so the e's cancel, so you just have the square root of 6. This would cancel out here, so that would be the square root of 2 times this square root of 2, which is the square root of 4, which is 2. Okay, so starting at number 70 here, we're going to use more of these rules. So the product rule, so if they're log of things being multiplied, you can separate them by addition. Quotient rule, if it's division, you can separate them by subtraction. And the power rule. Okay, so thinking about those 3 rules there. So if we want to expand this, this would be, since it's division, so it would be log base 4 of 6 minus log base 4 of 7. Okay, this one here, we can, let's first take care of this part, so it'll be log base 3 of 4p minus log base 3 of q. Okay, but this 4 and this p I can separate as well, so we can say this is log base 3 of 4, and multiply as add, so plus log base 3 of p, and then minus your log base 3 of the q. Okay, so this one here, let's take the division first. So it's log base 2 of 2 square root of 3. Division is minus log base 3 of 5p. Okay, now we can take care of this other stuff here too. So we can say this is, I'm just going to get kind of long here, I'm going to put it down here. This is log base 2 of 2, and multiply here is adding log base 2 of the square root of 3, and here minus log base 3 of 5, and this would be plus, but I'm distributing the negative through with that, so negative log base 2 of p. Okay, you could say this base 2 would be 1, so technically the correct answer would be 1 plus log base 2 of square root of 3 . Okay, so there's that answer. Okay, number 76. So we don't have anything with addition here, so you can't rewrite. This doesn't fit any of those properties that we've been talking about. I should have actually kept writing over there. Anyway, number 78, use the quotient rule. So it's log base z of x to the 5th, y to the 3rd, minus log base z of 3. And then I can use the product rule here. So we can say log base z of x to the 5th plus log base z of y to the 3rd minus log base z of 3. Okay, now I can use the product rule, which we haven't really done that. Take that 5, put it out front. So this is 5 log base z of x. Product rule, take the 3, put it out front. 3 log base 2 of y minus log base z of 3. Okay, so number 80, I know it's a cubed root, so I'm going to rewrite this as log base p of all that stuff to the 1/3 power. I'm going to use the product rule to take that out front. So I know it's 1/3 log base p of m to the 5th k t to the 2nd. Okay, I'm then going to use the quotient rule here. So I have the 1/3 out front, and then we separate this into log base p of m to the 5th. Dividing is subtraction, minus log base p of kt squared. Okay, the 5 I can bring out front here. So it's going to be 5 log base p of m. And I'm going to subtract both of these, okay, so using the product rule here, this one and then that one. So log base p of k, its product means adding, but I'm taking this and distributing it through as well, so it'd be negative log base p of t squared. Okay, once again, I can take this 2 using the product rule, 1/3 of 5 log base p of m minus log base p of k minus 2 log base p of t. You could take that 1/3 and distribute it through. You don't need to though, we can leave it like that. Okay, number 82, we're going to start going the other way. Okay, so division, sorry, minus is the product, the quotient rule. So this part here would be log base b of k divided by m. And I know that another quotient, right, minus. Okay, I'm sorry, did I write that problem down? Yeah, I did. Okay, so this would be the same as log base b of, and this is another division, so this brings it to the bottom, k over m a. Okay, 84. Using the opposite power rule, so I'm going to take this 1/2 and raise this all to the 1/2 power. So this will be log base y of p to the 3rd q to the 4th to the 1/2 there. And I can do the same thing over here to the 2/3 power. I'm going to take and distribute that through. So I'd have p to the 3/2 and q to the 4/2, which is 2. And this would be p to the 8/3 and q to the 6/3, which is 2. Okay, when I subtract, I can use that quotient rule. So this is going to be the log base y of p to the 3/2 q squared over p to the 8/3 q squared. Now I can work with my exponents here. Okay, so I'm going to divide these, right? So I have the q's will cancel, and this will be p to the -7/6. 3 minus, yeah. So you get common denominators, or just use your calculator or whatever to do that. Okay. 86. First thing I notice is this. I'm going to use the power. Okay. I noticed subtraction, so I'm going to use the quotient. So it's the 2y plus 5 divided by. I'm going to turn, this will be on the bottom, but I'm going to turn that to, you can leave it as 1/2 or square root, either way would be fine. And that would be our answer. Okay, number 88, aren't these fun? Okay, so I'm going to use the power here, take that over there. So I know this is log base 3 of this 16p to the 4th, all raised to the negative 3/4. Power here as well. So log base 3 of your 8p to the 3rd raised to the 2/3. Okay, dealing with our exponent stuff here. This would be log base 3. This would be, yeah, we can do 16 to the negative 3/4 and p to the negative 3rd. And let's continue to simplify this. So 16 to the negative 3/4. I'll kind of just do this on this side. Okay, so it's negative, so it's going to go to the bottom. Okay, and it'd be like the 4th root of 16 to the 3rd. And the 4th root of 16 is 2. And 2 to the 3rd power is 8. So it would be log base 3 of 1/8. And also the p to the 3rd is negative, so that goes to the bottom as well. Okay, and then here, if I simplify this part, 8 to the, this would be 8 to the 2/3 and p to the 2nd. 8 to the 2/3 would be like the cubed root of 8 squared. Cubed root of 8 is 2, 2 is 4. So this is log base 3 of 4p squared. Okay, now you can use the quotient. So this is going to be log base 3 of this. So 1 divided by 8p to the 3rd. And then divide by 4p squared, which is log base 3 of 8 times the 4 would be 32, p to the 5th. Fun stuff. Number 90, we can use the power rule here. So this would be log of x to the 1/2 minus log of y to the 1/3 minus log of z to the 2nd. Okay, so using the quotient rule, base 10 doesn't really matter here, but we'd have x to the 1/2 on the top. I'm just going to write that as square root. Okay, it's minus, so this is division, go 1/3 on the bottom, and also minus, so that goes to the bottom as well. Number 92, using the power rule, natural log of m to the 4/3 minus the natural log of 8n to the 2/3 minus the natural log of this. I'm going to take care of the exponent stuff here. So 8 to the 2/3. If you think about 8 to the 2/3 would be 8, the cubed root of 8 squared. So cubed root of 8 is 2, would be 4. And then we have n to the 2/3. Okay, so now I can use the quotient with the subtraction there. So I know it's the natural log of m to the 4/3 there, and 4n to the 2/3 there, and m to the 3rd n squared there. Okay. If you take care of your exponents here, this would be the natural log of dividing these gives you 4/3 minus this gives you negative 5/3. So if I put 5/3 here, and actually let's combine those ends as well. Okay, so if I have 2/3 and I'm adding that to multiplying this here, so add 2 to it, I get 2 and 2/3, which as a fraction is 8/3. Okay. For our purposes, we can leave it like this. In your textbook, they're going to have an answer like this, though. Notice they're all this, so we could say this is the cubed root. And to make it cubed root, it'd be 64, n to the 8th, and m to the 5th, if we think about cubed root of everything there. So either answer would be fine. Okay, using the change of base rule here, you can really use any base. Ones that we are commonly used, we could say this is log of 12 over the log of 9, and it's kind of like a base 10, okay? Or you could say another one that's commonly used is a natural log of 12 over the natural log of 9, because those are base e. You could use any base at all, really. But when you put this in your calculator, it comes up to be about 1.13. Approximately 1.13. Okay, and make sure you understand also how to just type this in the calculator as well, or type this into Desmos under functions. You can say log base whatever there, and you can type this in and get the answer as well. But also knowing this change of base idea is also kind of important. So we could say this is the log of 3 over the log of 1/2, or natural log, you can, or log base whatever, but log, yeah, anyone. And this comes up to be approximately negative 1.58. Okay, this is the same as log of 175 over the log of 200, which is approximately 0.97. Actually, yeah, 97. This would be the log of 12.7 over the log of 5.8, which gives you approximately 1.45.